I wanted to show you how to read a logarithmic axis. So we're pretty familiar with just regular standard linear scale, but this is different, so I'm going to show you how it works. So sometimes the lab manual will tell you this is a logarithmic scale. And so if we look at, we're going to not worry about the y-axis here, but we're going to look at just the x-axis. And so we're used to every large tick mark, so you'll see these large tick marks on my scale here. These would typically be worth like 1, 2, 3, right, or 10, 20, 30. But you'll see right away here, this looks weird. It's 1, 10, 100. And that's because it's logarithmic, so it goes up by a power of 10. And even over here, it starts at 0.1, right? So I'm not going to worry about that too much, but I want to talk about what happens here. So when you are looking at a data point, like let's say this location A versus this location B, it doesn't really matter what the y value is here, but just be aware this is a 1 and then this would be a 10 for your whatever this value is that you're measuring here on the bottom. So we use it to measure different things. Okay, so that's the first thing. But what happens if it falls in like a point here, C? What you're going to find is that the tick marks also are spread out a little differently than what you're used to. So I'm going to use this example from 1 to 10, and I blew it up here to make it a little easier to see. And so we can think from 1 to 10, we would expect to see 2, 3, 4, 5, all the way up to 10. And so normally we'd see 1, 2, 3, 4 evenly spaced, but this is logarithmic. So the first line you run into will be the 2, the second line you run into will be the 3, and then so on and so forth. And you'll see they kind of bunch up at the end. And that's okay. That's what's representing the way that this scale works. And so you're just going to want to count 5, 6, 7, 8, 9 all the way, and then you would get to 10. This isn't perfect, but you get the idea. They get closer together as you get closer to the next number. The same thing would work from 10 to 100. And so instead of, if we were to replace that, so let's do that really quickly. Let's say that we were going from 10 to 100, we would expect to see 20, 30, 40, 50, right? So this first line we run into would be 20, the next one would be 30, and so on and so forth until you got to 90 right before there, and then the 100 mark. So again, these tick marks aren't accurate, but it's just a way for you to understand how to read that. So in my example down here, this C point would be, it's right basically above this one. That's my third mark, so that would be 1, 2, 3, 4. So this value is 4, A is 1, and B is 10. So hopefully that helps you understand how to read these logarithmic axes, and now you can get going to your lab.